To part 3 of 5.4, inverse variation. So in the last part we're going to look at combined variation, specifically a type of combined variation called joint variation. So combined variation is when you have one quantity that varies with respect to two or more quantities. So that's the first one, combined variation. Basically, the key is two or more. So instead of just an x and a y, you might have an x and a y and a z and a w or something. And they could be any combination of direct or inverse variation put together. Joint variation is a specific kind of combined variation where the type of variation is direct. So one example might be this thing right here. You have your constant of variation k. It looks a lot like direct variation, except you have two variables next to k. The way that I would read this would be y varies jointly with x and z. So jointly is direct variation with more variables, essentially. But there are other types of combined variation where it could be some of it's direct and some of it's inverse. Okay, so let's look at a couple of examples. Although one of them I can see I typed something wrong, so we're going to fix that. All right, and the first example is an example of joint variation, because you can see the word jointly. So y varies directly with x and w, or sorry, jointly. So let's start by writing the equation. Y equals some k times x times w. So that y equals 18 when x is 9 and w is equal to 1/2. Write the function that models this relation, then find y when x is equal to 2 and w is equal to 13. So the procedure is just like the other examples that we did in the previous two videos. Plug stuff in, find k, use k, plug some more stuff in to find the variable you're missing. So let's see, y is 18, k we don't know, x is 9, and w is 1/2. So cleaning this up, you can take 9 and multiply it times a half and get 9/2 times k equals 18. Let's get rid of this 9/2, multiply by 2/9. So 9 goes into 18 twice, so it looks like, and then these are gone, looks like k is 4. 2 times 2. Okay, so the function is y equals k times, or whoops, got to plug in k, 4 times x w. Obviously you can't really graph this because you don't even know what these are weird variables, but well, if you could, I suppose, if you have a w axis, but we don't need to. Okay, so back to the rest of the problem. Find y when x is 2 and w is equal to 13. Okay, so y equals 4 times x, which is 2, times w, which is 13. So we just need to multiply. So that's 8 times 13, which is 104. Okay, our second example has an error in it. I forgot to type a very important word, so we're going to add that. It says y varies directly with x and the inverse of, I'm supposed to say the inverse of right here, the cube of y. Okay? So how would that look? Okay, so some of it is directly. It says directly with x, but it says inversely with the cube of y. So if we were to just do directly with x, it would look like this, k times x. But it's also inversely with the cube of y. So inversely tells you it's going to be in the denominator. And so in the denominator, you're going to put the cube of y, which is y cubed. The rest of this problem is pretty much the same. So we're going to plug in the information. It says such that z is equal to 3 when x is 8 and y is 2. So let's plug all those in. Z is 3, k is unknown, x is 8, y is 2. So 2 cubed. This is going to be 8k over 8, which those 8's are going to cancel. So essentially we have just 3 is equal to k. Okay, so the function would be, oh, not y, z equals 8, or sorry, 3 times x over y cubed. The last part of the question says find z when x is 6 and y is 4. So z is 3 times x over 4 cubed. That's 18 over 4 cubed is 64. So then we can reduce that to 9/32. It's going to give us a fraction. And we're done.